Hey guys, today's video will be about these two things. So we are going to implement an option in the executable that allows you to run a file and then start an interactive REPL. So an example of a program that does this is Python. Um, so if you type in Python in the command line, it takes you to the REPL, so you can run stuff like this. Now this behavior is similar to what we have until our Haskell and Lisp and Haskell program. Um, and also it takes a file name as an argument so that it runs a file if you provide a file name. For example, I'm going to say test py. I'm going to make a random file that does, I don't know, a Python file. If you provide an argument like the following, um, the Python interpreter will only run the file and then exit. This behavior is identical to the one we have implemented as well. You just run the file and the program is over. But there is a feature, a flag in Python that allows you to run a file uh, and then launch a REPL. Um, you can see this better if you have a function, if you have a user-defined function that, I don't know, that tells you if a number is even or not. So if you launch a plain Python REPL, it won't have the isEven function. But as we've defined the isEven function in our test.py file, we can use this function inside the REPL that was launched after loading the program. So we are going to implement this behavior. I'm trying to do this right now because uh, there's I think it's the best way to show that our uh, program works by launching a REPL and then uh, giving multiple inputs to the function and checking its output. Um, we don't have a function, for example, that uh, takes a number from standard input. We don't have a native function like that. So it's hard for us to uh, interactively test out the function by ourselves, other than modifying the code, then running the code again. So that's the main reason why uh, I want to implement this feature before trying out um, before trying to implement a a a simple program. So as usual, I should really make a function for this. Show tab line set no relative number. I'll close this, launch a new one. We should go into our executable. because I think it's the responsibility of the main module. So here we get our arguments. If it's null, we launch a plain REPL. If there are two arguments, if let's len equals length of args, if the length is 0, then we launch a REPL. If the length is 1, then we do this one. Otherwise, we do the same thing, but we check if if we want to check if the flag is passed correctly. We only want the -I flag to launch an interactive REPL. If tail head, oh darn it. Um, hmm. Too many arguments. Good AI. So the file name is okay. I think we're gonna do a pattern match here. Flag file name. Otherwise, do this one. Zoom out a little bit. Oh, we can actually do this. Oh, okay. Invalid flag. Only available. The only available flag is -I. If it exists, run file. Run file and then launch REPL. We should make should we make a function that returns an environment as well, or should we modify this function to return the environment? I think we should return the environment here and just ignored it in this section. Um, IO maybe environment. Return. How do you construct this thing? I can just use return, right? Return nothing. Map m, print results. And we do not Okay, first of all, we have to change this to run state. And then map m will return a list of values. State t of result. Okay. Yeah. So values and the resulting environment. You can print the values using map m and then return the environment like this. So wait. Run file name will return 2. This is not good. I don't like it. Okay. We do this and then return use void control monad. Control monad void. We run file, and then we'll receive an environment. Maybe n. Copy this one. Maybe n. Do. And then we pass the environment to the REPL prime function. foldable for M. Wow. This is so cool. Import data foldable for M. But what does this do? Map M with its arguments flipped. For a version that doesn't ignore the results, C for M. Okay. I didn't know maybe was it foldable. I saw someone doing. Oh, I saw someone inspecting the maybe type in a Haskell repo. So maybe I'll do that. Info maybe. It is foldable. It is a container after all. I mean, it just doesn't have to do anything if it's nothing. So I think the fold map function would be the same with its fmap implementation. Map. Oh wait, it's not this one. Or Okay, this is neat because it returns unit for us, so we don't have to do the heavy lifting. It's not heavy, but it looks better if you have a dedicated function. If you have a dedicated function, it makes you feel like you're doing it correctly because it feels like the standard library is acknowledging the fact that this is a common common pattern. Okay, anyways, we'll see if this works correctly right now. Oh wait. We write a function that tells you if a number is even or not. If equals 0 modulo n2, if it's equal to 0, then it's an even number, right? True, false. True and false. So it's working correctly. So now, so the point I was making is that if you have a function in your code, and you want to run it several times, we don't have a way to receive input from the user right now. So it's hard for us to test the code. We have to modify it um, like this. If you want to test out multiple arguments, if you have an interactive REPL, then that problem is it relieves the problem a little bit. Oh, wait. Oh, okay. Okay, so it printed out true and false, and now we're in this REPL right now. So we should try out our custom made function. And we can see that this function, even though it's user defined, we can still access it because we're using essentially the same environment that this code used. We're reusing the environment from our code, so that this is why it's working. So we can see that it's working correctly. So now we got this down. Now for the final goal of this series, making Lisp and Haskell, we will implement a prime number checker. A prime number checker checks if a number is prime or not. So it's relatively easy. This is something that beginner programmers would usually do. But it goes on to show that our custom-made Lisp is powerful enough to solve these kind of problems. Something that beginner programs would solve. So the reason why we're doing this is because it uses all of the constructs that we've made along in our development of this custom Lisp. So we will encounter many various constructs that we built by with our hands. So first of all, I'm going to write a prime function. So our primary goal is to finish the implementation of this function. It receives a single argument, and so a number, we suppose that this number is larger than 0, so it's equal or greater than 1. So first of all, we check if the number is 1, because one's kind of a special case. If equal to 1, then true. No, it's not true. It's not prime. If it is not equal to 1, then it must be greater than 1. So we can wait. We can start checking if some number is a divisor of that number of n. And I'm thinking if this one needs a helper or not. I think we'll need a helper. Is prime helper. And so this is the final destination. And this is a number that we're checking if x is a divisor of n. I'm not sure if I got the terminology right, but essentially we're checking if n is divisible by x. So now we will. So if x times x is if x times x is smaller than n, we can go on, because there's still a possibility that numbers larger than x might be a divisor of n. Oh wait, if it is equal, Yeah, there's a possibility that it might be equal. If it's equal and the modulo of n by x is equal to 0, then we return true. Oh, darn it. I'm just gonna use the file without an extension because the editor keeps bugging me with those red errors. If it is equal to 0, then we return true. Or if it isn't true, it must be false. So this was a true bench of this one. If it's not equal, oh wait, let's just do it this way. If x has become large enough that x times x, the square of x, is over n, we can just throw false. Otherwise, yeah, I think we can reuse this. Otherwise, we wrap it in an XSS expression. Oh, we don't have to. True. We shouldn't return false here, but rather we should do a recursive call. Is prime helper n plus x1. Oh, why is this showing? Let's just deal with the editor problem right now. Codium and then I think the error is coming from Codium. Is prime. What? Now it's working correctly. Okay, let's reopen it and get to the bottom of it. Type something. Use some parentheses. Leave some. Define foo. Let foo. That argument to pairs. Codium.mvim. Let's just disable Codium in the Lisp language. File type. Disable file types via config. Do I want to do this? Um, 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 no, I don't want to do that. It'll be too much of an hassle to do right now. Okay. But the good thing is, we finished writing our function. So the is prime function, if it is equal to 1, let's just say this. If it is lesser than 2. Otherwise, we call our helper. Prime. Oh no. Okay. It's the bracket problem again. The dreaded bracket problem in Lisp. Does not exist. Okay. Yeah. False, false, false. Why is it all false? What did I do wrong? Um, hmm. Is prime. Check my notifications real quick. Oh, this is not correct. Should be this. Oh, wait. Oh, this should be true. Wow. Rookie mistake. Oh, what? Oh, no, 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 no. No, no, no. This shouldn't be true. Um, false. 작으면 더 크면 false고. 아니지. 아, 완전히 잘못했다. 이게 이러면 false지. I was kind of caught up with writing Lisp code, and I was kind of stressed out. So my head didn't function properly for a moment. What? Why are you doing this to me? 이거 nx로 나머지 만약에 나눠져. 나눠지면 이거 하는 게 맞지? 그럼 true. 아니, 끝까지 왔으면 true를 돌려주는 거야. 이거 맞았어. 이게 처음에 맞았던 거야. 그리고 나눠 떨어지면은 false를 돌려줘야 되는 거고. 드디어 됐습니다. 2, 3, what, wait. 4가 왜, So I think we should check if x squared equals n because of situations like because of numbers like 4 and 9. 아니 잠깐만 이거 나눠 떨어지면 이게 펄스인 거지 바보야. 완전 프로그래밍 실력 완전 여기서 그 버스트 되네요. 이거 나눠 떨어지면 버스고 안 나눠 떨어지면은 이거 다음 거 해야 되는 거지. 아 진짜. 오케이. 아 이제 진짜 맞았어. 이제 진짜 맞았어. 아 okay. Now we have the complete program. Um, so now we can test out some larger prime numbers, and this will really make my computer work hard because this is essentially I mean, this one, it's a recursive function, but the stack size increases as you do more recursion because we don't have this code uh, is theoretically, well, I'm not that good at theory, but according to some production level language that I know, this code is if it's something if it's ran by some interpreter like the scheme interpreter, it'll be tail call optimized. Uh, Tail call optimization is essentially if you have a piece of code that is eligible for tail call optimization, the stack size won't grow even if you do a lot of recursion, uh, but only for code that can be optimized, tail call optimized. And this code right here that we have, it can be tail call optimized, but our interpreter does not do tail call optimizing. So our stack size grows as we do more recursion. Um, so I will, huh, large prime number. Nope. Our prime number should be in the range of an integer because that's how we programmed our interpreter. The number value is represented by an int type in Haskell, and the int type in Haskell, as far as I know, is 4 byte. Its size is 4 byte. So, so there's a limit to how large the number can be. I don't know. We'll try something like this one. I think this is large enough uh, to really test our interpreter. By testing our interpreter, I don't mean like anything big because we didn't do any optimizations. Um, so a number like this one. 오, 진짜 빠르다. 어떻게 된 거지? Let's try. Um, 2, 1, 4, 7, 4, 8, 3, 6. Okay, this is small enough to fit in our number range. So let's try this one. Wow, it is really fast. Wow, computers these days. Well, actually, this computer is from like 10 years ago, so um, but anyways, 진짜 빠르다. Um, to prove a point, I will now put in a prime, something that is not a prime number. Because our function could be just blindly returning true for any number. 8. Wow. Okay. I'm actually really satisfied with the performance. I mean, it's not me doing it. It's the computer doing it. I didn't do any optimizations, so. But anyways, I'm really proud of it. Wow. And I struggled a lot because I've never written a prime number prime number checker using recursion. This is a really uh, unfamiliar way of writing a prime number checker by using recursion, that is. Okay, now we got all our goals completed. So this will be the end of Haskell, writing Lisp in Haskell. I have had so much fun with it, and it was a new experience for me because uh, I was like live coding when I while recording, so it's very fun for me. The next video uh, will be about writing LLVM kaleidoscope, like following the LLVM kaleidoscope tutorial. So I'm really excited for that. The project is done in C++, which I've never written before. I have some of the tutorials, I have already followed some of the tutorials, mainly chapter 1 and 2. So I'll be beginning from that part, uh, which is the uh, part that becomes starts to become fun. Okay, uh, so okay, thank you for watching. Bye bye.